Hi-oh, here we are, color in our world. Why is the sky blue? That's a question asked by many people. I've heard people say, oh, I heard it was because of reflection off the water. No, not correct. Or the ice caps. No, incorrect again. It has to do with the size of our atmosphere, specifically the size of the particles in our atmosphere. These small particles tend to scatter the blue light. When you get bigger particles, you start scattering redder light. So small wavelengths are scattered by small particles, bigger wavelengths are scattered by bigger particles. And scattering is just a simplistic term for saying the atom absorbs and re-emits the light in a different direction. So if light had come from, let's say, a beam of light coming from here, that beam of light, that blue beam of light, might scatter to here and then towards your eye. In other words, it appears like the blue light's coming from some other direction than it originally did. Again, we call that scattering. Interestingly enough, our sun gives off white light. And if you remember from a previous podcast, white is composed of red, green, and blue. And in doing so, the blue gets scattered out, and what are we left with? Green and red. Oh, our sun appears yellow to us. In reality, our sky doesn't just scatter the blues, it really scatters the violets even more. But our eyes aren't very sensitive, so we don't see those. What about on the moon? Did you know the sky is black? The reason is there is no atmosphere on the moon, so light doesn't get scattered. What about clouds? How come they're white? You should be able to answer this by now, because we know light is composed of red, green, and blue. We know particle size determines what gets scattered. So that should tell you the particle sizes that make up a cloud are of all different sizes. When you see pollution, we get kind of a bluish whitish appearance that again tells you that those lower frequencies are scattered out. So why are the sunsets red? Well, red is getting scattered. Okay, the two things that can be going on. We can have large particles in the atmosphere, lots of pollution to give us a really dark red or deep red, or the reds start getting scattered out even more because there's so much more atmosphere for the light to go through. In other words, some of the red gets scattered because our atmosphere does have some bigger particles. And the more atmosphere you have to go through, the more of those particles you're more likely to encounter. To give you a different perspective about that more atmosphere, you can see the distance when the sun is setting or rising versus here. Definitely more atmosphere to go through, more scattering. What about water? Why is it cyan in color? Because it turns out water is weakly resonant to red. So red, remember, white light, red, green, blue. You get rid of the red, you absorb that out, and you're left with greenish blue. So think about this. Lobsters, crab, they hide in the deep bottom of the water. They're red in color, but red doesn't make it. So if there's no red to reflect, what color do they look? Black, of course. Lastly, we have to talk about atomic spectra. We have these instruments called spectroscopes, and it divides up the light, much like a prism does, into its constituent colors. Sometimes we get a hot gas producing things called emission lines. Essentially, electrons are jumping orbits. Let me show you in this case right here. An atom, a photon comes in and it jumps up, and when the photon leaves again, it goes back down, and in doing so, we get a bright light, a bright band of light at that particular frequency. So here you can see different types of light sources showing their fingerprint, their atomic fingerprint. Sometimes we don't get emission spectrums, we get absorption lines. We have a cold gas cloud between us and the light source, and usually this is in terms of astronomy, and that cold gas is made up of some element, and those specific elements absorb out specific frequencies of light, and so we have parts that are missing.